Hi Year 11. Today what we're doing is we're looking at conditional probability. Conditional probability is the probability that an event A occurs when it is known that another event B has already occurred. Conditional probability is in multi-stage events when the outcome of the second event was dependent on the outcome of the first event. This includes when selections are made without replacement. The probability of event A occurring given that event B has occurred is denoted by P bracket A line B bracket, which reads the probability of A given B. Now we have a formula to find out the probability of A given B, and it is this one here. Now this formula here is on our reference sheet, so we will go and annotate in a second. I'll just do our little note over here. But what we have is we have the probability of A given B is equal to the probability of A and B over the probability of B. So we can also read this as the number of elements in A and B over the number of elements in B. We can also see it flipped so that we can find the probability of B given A is the number of elements in A and B over the number of elements in A. So what you want to know is what is the probability that is given. So we're not what the probability of finding. So the probability that is given goes as the denominator. Whereas, so for the first one, we have the probability of A given B. So our probability of B is on the denominator. Our second formula here, we have the probability of B given A. So we've had the probability of A on our denominator. Flipping to our reference sheet now, we're just going to denote that we know this formula. Obviously, we can't have the probability of B equal to 0 because we don't have fractions with denominators of 0. So this is our conditional probability formula. Actually, I'm going to write conditional and then probability here. And it is the probability of A given B. Okay, back to our notes. So we have that with conditional probability, knowing that an event has already occurred reduces the sample space. For our first example, we're going to look at something with a Venn diagram. So we have all 30 students in a class study either history or geography. If 19 do geography and 13 do history, we want to find the probability that a student does geography given that the student does history. So the first thing we're going to do is we're going to display this information in a Venn diagram, which I've already drawn up for you. We are going to put our geography and history labels on our Venn diagram, and we're going to work out our sections of our Venn diagram. So we have the probability of geography and history, which is so the probability of both. How we calculate that is we add if they only do geography, or if they do geography, if they do history, and we take away our total number of students, which is 30. So 19 plus 13 minus 30 is equal to 2. So this means we have 2 students that do both. To find the probability of geography only, it is going to be our geography is 19 students do geography minus 2 doing both. So that gives us 17. And then we're going to have the probability of history only is equal to, we have 13 students doing history minus 2 doing both, so we have 11. Now our numbers 17, 2 and 11 must add back up to 30. Now what we're going to do using our conditional probability statement, or formula, we're going to work out how we're going to work out this conditional probability. So the question is asking us to find the probability that a student does geography given that the student does history. So what this means is we're doing the probability of the student does geography given that they've done history. So the probability of G given H is equal to the probability of G and H over the probability of the given thing, which is history in this case. So we will have the both. So the probability of G and H, we have already found that up here, and it is in this part of our Venn diagram to be 2 over the probability that they do history is all of, I'm just trying to work out, it's all of this circle. So every single person that does history, we are told this information in our question, but it is the 2 plus 11, which in this case is 13. So that means our probability of G given H is 2 over 13. I don't think I need to write that in blue. Can if you want, or you can write a therefore statement. Okay, moving on to our second example, we have the table shows the results of a survey into vaccinations against a new virus. We want to find the probability that a person selected at random is not vaccinated. So to work out if a person is not vaccinated, the type of table we have here is a two-way table, and we can move the information from our two-way table into a Venn diagram if we need, or we can use our two-way table straight off the bat. So with our vaccinated and infected, we have our both section. So our both section is here, so that they are vaccinated and they are infected, and so we can put that number of 13 there. Now say this is vaccinated, this is infected. Now we'll have the people that are infected but not vaccinated. So this bit of information goes in here. So that will be 159. We have our vaccinated but not infected is going to go in here, which is our 227, and we will have our not vaccinated, not infected goes on the outside of our Venn diagram, so down in the corner, and that's number 38. Now, something you need to notice with your two-way tables is for your totals, all of your rows should add up to these totals, and all of your columns should add up to the totals, and then both the row and the column should add up to this massive total here. Okay, so to find the probability that they're not vaccinated, so probability of not vaccinated is going to be this total of not vaccinated, which is 197, over the total number of people in the survey, which is 437. We just want to check on our calculator whether we can simplify that, and we cannot. Okay, now we want to find the probability that they are not infected given that the person is not vaccinated. So here we have a conditional probability statement, and what it is saying is the probability of not infected given not vaccinated. Murphy, no. Sorry guys, not vaccinated. Murphy. So how we can write this is the probability. Murphy, I'm trying to film for school. Come on. Thank you. So not infected, we can do an I with a line. Given not vaccinated, a line. V with a line. Okay, so we have that this is the probability that they are not infected and not vaccinated over the probability that they're not vaccinated. So the probability that they're not infected and not vaccinated was that 38 over the probability that they're not vaccinated was that 197. So the probability of the person being not infected, given that the person is not vaccinated, is 38 over 197, which does not simplify any further. For C, we have to find the probability infected, given that the person is vaccinated. So we're finding the probability of infected, given vaccinated is equal to the probability of both, so infected and vaccinated, over the probability of vaccinated. So the probability of infected and vaccinated is that yellow number of 13 over the probability of vaccinated. Now, vaccinated is this total down here of 240. Now, 13 over 240 does not simplify, so that is our final answer. Our last one here is we have that to find the probability that they're vaccinated given that the person is infected. So we'll have the probability of vaccinated given infected is equal to the probability of vaccinated and infected, so both, over the probability of infected. So we have the probability of vaccinated and infected was that yellow number of 13, and the probability of infected, that is this number over here, which we'll just do in bright blue, which is 172. So that is over 172, and again, that does not simplify. Okay, we have two more examples to do. We have that Georgia is an athlete who enters a swimming and running race. She has a 55% chance of winning the swimming race and a 41% chance of winning both races. We want to find the nearest whole percentage, the probability that she wins the running race if she has won the swimming race. So this is a conditional probability statement that we're trying to find. So we're going to put this information into a Venn diagram so it makes more sense. So we have swimming, we have running. Okay, so we have information that she has a 55% chance of winning a swimming race. 55% chance of winning a swimming race. So that comes from this bit of information here. So that is this whole circle needs to add up to 55. Now, we get told that the probability that she wins, she has a 41% chance of winning both races. So 41% chance of winning the swimming and running race is 41%. So that means this section in here is 41%. So what this means is we want to work out swimming only. Actually, we don't even need to work out swimming only, but we could work it out to be that would be 14% there by going 55 minus 41. We don't really need the Venn diagram. We don't really need to work that out. It just sort of helps to visualize sometimes. So the question that we've been asked is to find the nearest whole percentage. So nearest whole percentage is key there. We want to find the probability that she wins the running race if she has won the swimming race. So she's already given, so we're finding the probability that she wins the running race given she has won the swimming race. So this is the probability of running win given swimming win. So this will be the probability of running and swimming over the probability of swimming. Now, running and swimming is exactly the same as swimming and running. So we'll have that this is equal to our 41 over our swimming, our probability of swimming, which is just 55. Now, even though these were percentages, when we go 41 divided by 55, we're going to get a decimal. So we need to times by 100 so that we can get this as a percentage. So when we do 41 over 55 times by 100, we get 74.5454 ... Okay, so this is to the nearest whole percentage, 75%. So the probability that she wins the running race if she has already won the swimming race is 75%, which I think is really good odds and chances. Okay, our last example that we're going to do, just double checking, is about a zoo. Again, there's a lot of information and I'm choosing to put this information into a tree diagram to help me out. So a zoo has a probability of 85% of having an article published in the newspaper when there is a birth of a baby animal. When there is no birth, the zoo has a probability of 23% of having an article published. The probability of the zoo having an animal born at any one time is 45%. We're going to find the percentage that a baby animal was born given that the article was published. Okay, so here is our question. Find the percentage that a baby animal was born given that the article was published. That's what we're being asked to do. So probability of baby born given article published. What we're going to do is we're going to use this information, put it in a tree diagram to help us out. The first thing we're going to do is we're going to let, and I'm just going to write this underneath, going to let B equal birth of baby animal. And let A equal article published. Okay, so the first event or outcome that could happen is the baby being born. So we could have the probability of the baby being born or the probability of or the baby not being born. So we have the information of that a probability of 85% of having an article published in the newspaper when there is a birth of a baby. And we also have, when there is no birth, the zoo has a probability of 23% of having an article published. And the probability of the zoo having an animal born at any one time is 45%. So the first bit of information goes here, and that is having an animal born at the zoo. So we have 45% there. I am going to write this on this branch here. We then have to find out the probability of the baby not being born, which is just 1 or 100 minus 45%, which is 55%. Our second outcome is if they write an article or they don't write an article after the baby is born. So we'll have or the baby not being born. So we have article, no article, or not an article, and not an article. So the probability of, it's a probability of 85% of having an article published in the newspaper when there is a birth. So after a birth, we'll have 85% chance of an article. So we'll have 85% chance on this branch here. Now, when there is no birth, the zoo has a probability of 23% of an article being published. So when there is no birth, it is a 23% chance of an article being published. Now, each of these pairs of branches have to add up to 100%, or if we were using decimals or fractions, have to add up to 1. So we'll have that it is 15% after birth that there's no article published, and 77% when there's no birth, there's no article published. We're then just going to write our outcomes and then work out our probabilities. So we'll have the probability of a baby animal being born in an article. Then we'll have baby animal no article, no baby animal article, and no baby animal no article. So this is the probability of baby animal and an article is equal to 45% times 85%. So that is 45 over 100 times 85 over 100 times by 100 altogether is equal to 38.25%. The probability of a baby animal being born and no article being published is 45% times 15%, which is 6.75%. The probability of no baby animal and an article being born and an article being published is 55% times 23%, which is 12.65%. And the probability of no baby animal and no article is equal to 55% times 77%, which is equal to 42.35%. Now those percentages should all add up to 100 if we've done everything correctly. So what we need to do now is we need to look at what the question is asking. So the question is asking to find the percentage that a baby animal was born given that an article was published. So what we're finding is the probability of a baby animal given article published. So we need to find the probability of a baby animal and an article over the probability of an article. Now we have just worked out the probability of a baby animal and an article being this up here. The probability of baby animal and an article is our 38.25%. But we do not know the probability of an article. So a probability of an article is when an article is written here and an article is also written here. So what we have to do is we have to add these probabilities together to work out what the probability of A is. So we'll have the probability of A is equal to the probability of B and A plus the probability of not B and A. So this is equal to 38.25% plus 12.65%, which is equal to, I believe it is 50.9%. So we can then put this in here, 50.9%. So to work out, because we do want to find a percentage, we are still going to have to multiply this by 100, even though these are already percentages, because we have that 38 is less than 50, which will make the answer to this fraction less than 1. So to make it a percentage, we have to times by our little 100 here. So we get the answer to be 75.147347774, which is going to be 75% to the nearest whole percentage. Alrighty, what you guys are going to do now is you're going to do exercise 707, I believe questions 1 to questions 17.